In today's video, we're going to be taking a look at similar shapes, which takes a look like, especially, first we'll deal with triangles, which we've seen in congruency, looking at triangles that have similar properties, which will help us solve problems by saving us some time. Then we'll look at how we can link this into areas and volumes as well. So, if we take a look at the two triangles here, as you can see, both triangles have the same value of angles at each corner, but one of them is the first triangle is scaled up to make the second triangle. So when we talk about similar 2D shapes, shapes will have the same dimensions, but the lengths will have been scaled up or down. And then we just need to work out what the scale factor is to find any missing lengths. So let's take a look at this first example. We're given two triangles. We're told they're similar, so we can assume they're going to be proportional. And we've got two missing lengths, missing length of y and then a missing length of x. The first thing we want to do is work out the scale factor. Well, I know one length in both triangles, which is this length here. I know that QP is going to be proportional to ML, so the scale factor is going to be 21 divided by 15, which simplifies to 7/5. If we're going from the smaller triangle to the bigger triangle, you times by this, and if you're going from bigger to smaller, you divide by this. So, to work out x is on the smaller triangle, so you know it's going to be a smaller length. So we need to do 14, which is the corresponding length, divided by 7/5, which is the same as 14 times 5/7, which will give us 10 centimeters. And then for y, we're going from a smaller length of 18 to a bigger length. So you're doing 18 times 7/5. You do 18 times 7, divide that by 5, and you get a value of 25.2 centimeters. Makes sense since it's bigger than 18. Now, for this next example, we're going to look at a different way to solve this, which is using proportional ratios. So first we need to calculate the length of CD. Now you know CD is the base of the larger triangle on the outside, and 5 is the base of the smaller triangle. So CD divided by 5 is going to be the exact same as any of the other two lengths when you divide the bigger one by the smaller one. So if you look here, the bigger length on this side is 4 plus 6, which is 10. And then the smaller length on the triangle is 4 and not 6. So the smaller length is 4. So to work out CD, we just need to times by 5 to get rid of the denominator. It's 5 times 10 over 4. 50/4, 25/2, so that's 12.5 centimeters. Next, we're calculating the length of ED. Now, you notice ED isn't part of the smaller triangle, so it's not going to be proportional. What you need to do is you need to work out the whole length of AD and then take away the 4.8. So ED would be AD, take away that 4.8. So once again, I will work out the scale factor and times it, or use the fraction method we just used. So we'll use the fraction method. So AD divided by the corresponding side, which is 4.8, is the same as the large length of 10 divided by 4. So AD is going to be equal to 4.8 times 10/4. You're doing 4.8 times 2.5. which will give you a value of 12. And then once again, you want to work out ED, which is this value minus 4.8. So ED is 12 minus 4.8. So ED gives us a value of 7.2 centimeters. Next, look at another question. It says we've got two triangles here. The diagram shows triangle ADC, which is the big triangle, Now, since these lines are parallel, we can assume these two triangles are similar. So we've got the small triangle, which is AEB, and then the large triangle, which is ADC. We need to work out the length BC. Once again, that's the big length take with the small length. So BC is AC, the whole length, minus 14. So use the fraction method again to work out AC. So AC divided by the smaller length, which is 14. We're given the other two here. So once again, it's the bigger length over the smaller length. So AC is 14 times 20 over 16, or 14 times 5 over 4, if you need to do this on a non-calculated question. And then AC should give us a value of 17.5 centimeters. And then once again, to work out BC, 17.5 take away 14, so BC is going to be equal to 3.5 centimeters. Now we're going to take a look at a harder question. Now this has come up on a previous November paper, so it will be helpful to look at. The reason it's hard is because you need to find two possible values of x, which is a little bit different to what we've been finding before. So here we're given a triangle where I've got a smaller length of 8 and a larger length of, this would be 8 plus the x, so it's x plus 8. And then we've got a smaller length of 12 and then a larger length of 15. So using the fractional method again, the larger length of x plus 8 and the smaller length is 8. And then when you do it for the other side of the triangle, so that's the same as the larger length of 15 divided by the smaller length of 12. So you times both sides by 8. So x plus 8 is 8 times 15 over 12, which will give us 10. And then you're going to be taking away 8 from both sides, so x should give you a value of 2 centimeters. Once again, it says state any assumptions you made in your working. So the assumption here is that the length AE, which is 12, is proportional to AD, which is 15. Because once you assume that the lengths are proportional, you can use the fact that they are similar triangles. So you need to state that there. If they don't tell you in the question they're similar triangles. Now, to work out the second value of x, it's a little bit harder. You have to use another proportional method here. So we'll draw out two triangles, a big one and a small one. So in the small triangle, I've got lengths of 12 and 8. And in the big triangle, I've got a length of 15 over here, and then x plus 8 over here. Now what we're going to assume is that if I divide the smaller length by the bigger length on the other side, it's proportional to this bigger length divided by the smaller length on this side. So instead of looking like we did earlier, we had the lengths on the same side of the fraction. This time we're looking at lengths on the opposite side of the fraction. So the way we're going to set up 15 divided by 8. So the bigger opposite length divided by the smaller opposite length is the same as the bigger opposite length of x plus 8 divided by the smaller opposite length of 12. We times both sides by 12. So x plus 8 is going to give us 45 over 2, or 22.5. So x take away 8 will give us 14.5 centimeters. So the first one, we do it normally. We use a fractional method to work out what x is. If they ask you to work out a second value, then you use any other proportional relation. So the relationship we used here was the fact that we assumed that AB, this small length, is proportional to AD. It's proportional to the opposite bigger length. Now, moving on. After you've done similar shapes, we'll be doing the 2D shapes. You can also now use this to work out similar areas and volumes that for shapes that have just been scaled up. Now the notation we're going to use, when we worked out the scale factor of length using those fractions, we're going to denote that scale factor as k. Now, if we're working out area, we're going to change at maximum two sides of our shape and then times them. So if the scale factor for the length is a, this time the scale factor is going to be changed twice, so it becomes k squared. Then similarly, if we work out the volume, we times our lengths by k cubed. You always want to just state this at the start and then you can use it later on in the question. So first question here, we go from lengths of 2 to 6 and we want to work out the area of the large shape. So we first work out k, which is 6 divided by 2, which is 3. It says the area of the smaller shape is 7, so to work out the area of the larger shape, you do this times by the scale factor of 3 squared, since it's area, so you're doing 7 times 9, which gives you 63 centimeters squared. Make sure you're getting the correct units here. Next, so we've got a volume question here, so once again we'll label out length of k, area is k squared, and volume is k cubed. It says here, the length of A is 4 and the length of B is 6. So k is 6 divided by 4, which is 3 over 2. So this is 3 over 2, and this is 3 over 2 squared, and this is 3 over 2 cubed. So we need to work out the volume of the larger cylinder. We know the volume of the smaller cylinder is 80. So to work out the volume of B, it's this 80 times by the scale factor cubed. Multiplied by 3 over 2 cubed. We'll do this very quickly on our calculator. And it gives us a value of 270, and the units here are centimeters cubed. Next, so this time we're given a question without any diagrams, so you just want to read the question carefully, but once again, just like we did earlier, you want to state your scale factors, length of k, area of k squared, and volume of k cubed. A quick thing to note, the question here doesn't reference area but surface area, but since surface area is just a lot of areas added together, it's still going to remain k squared since you're still working out an area. It says the surface area of shape X is 450 and then for shape Y is 800. So to work out the scale factor, but you've got to be careful. Since we're given area, instead of working out k, this time we're given k squared. So k squared is 800 divided by 450. And then we want to work out what k is. So we're going to do the square root of 800 divided by 450, which will give us 4 over 3. If you simplify the fraction above, it would have given you 16 over 9, and then you can square root it. The reason I want to find k is, it's easier to go from k to k cubed, rather than from k squared to k cubed. Now, it tells me the volume of the smaller shape is 1350, we need to work out the volume of the larger shape. So the volume of y is 1350 times by our scale factor cubed. So do 1350 times 4 divided by 3 cubed, which will give us a value of 3,200. And then once again, the units here are centimeters cubed. Right, the last question we'll do. So we've got two cones which are mathematically similar, so you can assume we have proportional scale factors of k, k squared, and k cubed. It says the ratio of the volume of cone A to the volume of cone B is 27 to 8. So volume of A to volume of B is 27 to 8. So that must mean the scale factor k cubed is equal to 27 divided by 8, since the ratio is just another way of representing a fraction. So we cube root to find k, which is 3 over 2. So that's the scale factor. So the surface area of A is 297. We need to show that the surface area of B is 132. So if you know that the surface area of B is the smaller shape, we're going to divide by the scale factor. So the area of B is the area we're given of A, which is 297, divided by our scale factor, which is 3 over 2 squared. So on our calculator, we're going to do 297 divided by 3 over 2 squared, which gives us, as we have in the question, 132 centimeters squared.